All right, so we've been simplifying radicals, meaning you cannot have anything left underneath a radical that's a perfect square. But now we're going to be working on adding and subtracting to put these together. You have already worked on adding and subtracting with variables. So how do you do that? How do you add or subtract variables?
You add them.
Add what?
The variables.
But what do you combine when you're working with variables and you're adding and subtracting? Like terms. And then what part? It's the numbers in front, the coefficients. That's what you're going to combine. Do you do anything to the variable? You find the like term, but do you put a square with it? Do you change the variable at all? No. That's the same premise for adding and subtracting radicals. Treat the radical as if it were a variable. And you're only going to combine like radicals by adding or subtracting the numbers that are outside the radical. You don't add anything inside the radical. And you don't cross over. You don't go, oh, well, I could simplify here. You know, again, we're not crossing over from outside to inside. It has to remove itself from the radical to be able to change anything on the outside. So, number one, super easy. We have a 2 radical 5. Now, I'm going to suggest, not for this lesson necessarily, but there's going to be some things we do in the future that you need to be real aware of what number is in front of the radical. So I'm going to just put a 1 in front of the 1 radical 5. That plain radical 5. So when you combine those two, what do you get? Those are our like radicals. Look at the signs. 2 minus 1. So we would have 1 radical 5. And then we only have that negative 2 radical 6. We don't have another radical 6. So that would be your final answer. You won't say radical 5 plus radical 6 and make any changes like that. All right. 3. What would the final answer be? What do you get when you combine your radical 6s? 0 radical 5. So how many radical 5s do we have?
4.
If it's 0 radical 5?
0.
We don't have any. Right, 0. So it's thrown out. So what's your final answer?
2 radical 5. Yeah. 6.
Your 2 radical 5. Abels?
I'm a little confused here.
Okay, where are you confused? Do what?
Like if it's on like number 1, do you like keep?
Okay, let's rewrite it. You put everything that's alike. So we have a 2 radical 5. And we have a minus 1 radical 5. And then we have a minus 2 radical 6.
Is what's alike? Is that what's in the radical?
Like terms. The radicals are the same. We treat the radicals like variables.
But it doesn't matter what's on the outside if it's.
Well, it matters because that's what you combine. You take the 2 and the negative 1 and you combine those.
Like the outside doesn't have to be like terms, the inside has to.
No, it's like if you have 3x plus 7x. What is that?
Like terms.
But what is the answer?
10x.
10x. So the 3 and the 7 do not have to be the same. Same thing for radicals. The numbers outside do not have to match. Just the radical itself.
Okay, that's what.
Does that make sense? And then like we didn't change anything with the x, you don't change anything with the radical. All right. So look at number 5. And it never hurts to just underline what's alike and combine that and then see what's left. So what is the answer? What's the first answer part that you have for number 5, Mary Ainsley? Annalise? Elise, I'm sorry. I went, it's going to go and fair. Elise, what would be the first thing you would put? 5 radical 2, 2 plus 3. And how would we end it, Boyd?
2 radical 6.
Plus 2 radical 6. Now, 6 I know is not a prime number. It can break down to 2 and 3, but neither of those are perfect squares. And so the 6 just stays a 6. All right, now there's a little difference for number 7. Who can tell me what we would do with 7? Break down the 12. So we already have, with the 12, a negative 3 that we're going to work with because it's the number outside. 12 is going to break down into 4 times 3. So what are we left? What comes out? 2. All right. And then what does that mean the first radical becomes? Negative 6 radical 3. And then we keep going. Plus 3 radical 3. What's our final answer then? Negative 3 radical 3. Ended up creating where the radicals were just alike.
So if they're the same, if it's like on number 3, if they're the same, but one's negative and one's positive, do you just subtract it all?
But you're combining positive. How do
You just make it.
you just combine a positive and a negative number, as long as your radicals are the same.
Okay.
All right, you work number 9. Oh, work 9 and 11. And hint, you'll have 1 radical for your answer for both of those. Charlotte, what did you get for number 9?
3 radical 3.
Perfect. And Fair, what'd you get for 11?
-2 radical 5.
Negative 2 radical 5. Any questions on those?
Work 11.
Yeah, number 11.
Sure. I don't move. Oh, erase. Okay. So 20 is going to break down into what?
4 5.
4 times 5. What comes out?
4.
4. And we already have out there, it was a negative, so that's a negative 1 times 2. Okay, so we have negative 2 radical 5. All right, then we take the rest of it, and we have a negative 2 radical 6 plus 2 radical 6. Negative 2 plus 2 is 0. So we don't have any radical 6's involved. It's like you don't ever have a 0x.
Can you get like a no solution?
What?
Can you get no solution if they all cancel out?
You would have 0, I guess, is your answer. Yeah. All right. The back. Yeah. Same premise, just a little more breaking things down. Think about perfect squares that you can use to break the numbers down. Okay? So what would you think about for 54?
6 and 9.
So I would use 6 and 9. What about 24?
3 and 8.
I wouldn't do 3 and 8.
4 and 6.
6 and 4. Because it's perfect. You're using perfect squares. Will 3 and 8 work? Absolutely. It'll just be more factoring. What's in front of the radical 54?
-1.
-1. So we want to make sure we see that. So 2 radical 6, we don't break that down at all. And then 54, 9 times 6. The 9 comes out as a 3. And it's going to be multiplied by the -1, so minus 3, radical 6. And then the 24 is going to be 6 times 4. What is the 4 going to come out as? A 2. So plus 6 radical 6. So what's the final answer? 5 radical 6. Okay, I'm putting a 1 in front of this radical 5. All right, what happens with 15? What breaks down? Into what? 4 times 5. 4 comes out as a 2. All right, so we have 2 radical 3 minus 1 radical 5 plus 4 radical 5. So what's our final answer?
2 radical 3 plus 3 radical 5.
Yep, 2 radical 3. And then -1 plus 4 gives us 3 radical 5. Are y'all finding it easier than you thought it would be? It's a little, it's different what you've been doing, but it is not difficult.
Wait, how do you get 3 out of 5?
You can move it back up. So we had -1 radical 5, and then we had a 4 radical 5. When we broke down the 20, the 4 came out as a 2, but it was combined with the 2 that was already in front of radical 20. All right, what are we going to, again, we're going to be breaking down the same as we did for 13. So what's in front of the radical 5? -1. So I'm going to put that one down. So what 2 factors will we use for 45, Lillian?
5 and 7.
That's 35.
Oh, 5 and 9. Wait.
9 and 5. And the 9 comes out as a
3.
3. Good. And we combine it with the 3 that's already there. So I'm going to move this down a little bit. So we have -1 radical 5 plus 9 radical 5. And then the 54 is going to do what, Abels?
The 54 is going to break down to 6 and 9.
6 and 9. The 9 comes out as a 3. So minus 6, because we had to multiply it by the -2. Radical 6. So, what's one of the clumpies, JoJo?
Yeah, I was still working. Would be 5 radical 5 minus 6 radical 6.
All right, we have the -6 radical 6 is right. But you had -1 radical 5 plus 9 radical 5.
8 radical 5.
8 radical 5. Good. Do y'all see how we got the 8 radical 5? Because when we broke down 45, the 9 came out as a 3, but we had to multiply it by the 3 that was already there. Y'all don't lose that number that's already out there. All right, 19. Oh, good. We only have to break down one number. And that one is 54. And we just did that. So I think we look back and we use those same numbers, 6 and 9. Which one comes out? 9. All right, so at this point we have -2. Whoops, sorry. I meant to put -1 radical 2. Minus 9 radical 6 plus 2 radical 2. So what would be the final answer for this, Avery?
1 radical 2 minus 9 radical 6.
Yes, ma'am. 1 radical 2 minus 9 radical 6. All right, what I want you to do is 21 and 23. And then I'm going to call on you to tell me a clumpy here and there. There are 3 clumpies for 21 in your final answer and 2 for 23 in your final answer. I'll give you just a second to work that.
Will there ever be 3?
Pardon?
Can there be 3? Like, would there ever be 3?
Well, there's 3 in 21, but there's only 2 for 23.
So there can't be 3?
Yeah.
Okay.
Anna Christina, what did you get as 1 clumpy from 21?
Negative 7 radical 3.
Perfect. What would be another one, Gabe, from 21?
Negative 9 radical 2.
Perfect.
Wait, Dr. Graham, how'd you get 7 for the first one?
We had to break down 12.
Yeah, I get 4.
So the 4 comes out as a 2,
Yeah.
and that gives us negative 6. And then the far right was negative 1 radical 3. Negative 6 plus negative 1.
Okay.
Then how would we end it? I was going to call on you, Boyd. What was the last one that you had for 21?
4, positive 4 radical 5.
Perfect. All right, any questions on 21? Do y'all agree? All righty, the last one, 23. What did you get for one of the clumpies, Elise?
Negative 2 radical 4.
Negative 2 what?
Radical 4.
Oh, no. Don't add the inside numbers. Don't add your radical.
No, I meant 2.
Good. Phew. All right, negative, because you got the outside right.
Yeah, I just wrote something down. I got the wrong number.
Negative 2, radical 2. Oh, good. And then how would we end it, Eli?
Negative 6 radical 5.
Perfect. All right, do we need to work that? Are y'all good? Making sense? Can anybody tell me what the homework is? Evens. All righty.